Welcome to Solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay, Chapter 7, Section Problem 40. This is kind of a big one. Consider the balanced equation. We've got 2 N2H4 plus N2O4 goes to 3 N2 plus 4 H2O. And we're supposed to look at a chart that's in the book, and I've attempted to recreate it with a crude picture and drawing here. And we're supposed to complete the following table and show the appropriate number of moles of reactants and products. Okay. If the number of moles of a reactant is provided, fill in the appropriate amount of the other one, and vice versa. Okay, so we just got to fill in this chart. And I don't believe it's drawn in the book, but I have drawn in the coefficients for the balanced equation. And this is kind of a good way to kind of think about and look at the way that stoichiometry affects how much of a reactant would be consumed or how much of a product would be formed if everything was perfect. So in the first test tube or number or blank that's in your chart, we can see that we've got two N2H4s, and that happens to be the stoichiometry of the molecule. So if there's two, and this is reactant, so this would be something that would be consumed. So if there's two N2H4s consumed, well, then there would also be one N2O4 consumed. So, obviously this is going to go along just with these numbers, and it's supposed to be that easy and simple. It's just supposed to highlight the fact that, you can look at these coefficients and know what's going to happen intuitively. Okay, well, let's go on to 2. So number 2, we've got 5 N2O4s is our starting position, and that's got a stoichiometry of 1. So really we can, should be able to just multiply everything by 5. Right, so 5 times 3 is 15, and this should be 20, and 5 times 2 is 10. Okay, what about 3? So we can see that this one has more of a relationship of like 2.5 times the n. So what if we, and it's not what if we, what we should do is then multiply the coefficients by 2.5. So, okay, so 1 is 2.5. 2.5 times 3 is 7.5. For 1, we got 5. 2.5 times 2 is 5. Right? Okay. For 2, now this is another, in 4, we have 2.5, what I guess it's moles, 2.5 moles of N2H4, and has a stoichiometry of 2. So really, there would be 2.5 divided by 2 is the ratio. Right, for 4, right? Whatever that number is, you multiply that as. Okay, so I happen to do this in an Excel spreadsheet in a table, and if you have a big list of problems like that, it's often easier to get through a bunch of numbers because you can do a lot of these calculations right in Excel. But when you multiply 1 by whatever that number was, it happened to be 1.3, so that number is 1.3, 3.8. Times the stoichiometry is how much we're going to consume. And for 4, it's going to be 5. 4.2 is what we have to multiply everything by in test tube number 5 or experiment number 5. So we'll have 12.6 of the N2, the nitrogen gas, 16.8 for the H2O, and then for the hydrazine, the N2H4, that will work out to be 2 times 4.2, which is 8.4. And then the conversion unit, when we divide 11.8 by 3, which works out to be the value for the N2O4 always, is 3.9. And then this will be 7.9 and 15 0.4, no, 0.7, 15.7. Anyway, so in order to figure out what the conversion ratio is to fill in a chart like this, you just divide any of the numbers by their coefficient, and then you can go from there. Anyway, good luck studying. Well, yeah, good luck studying, everybody.